So hi everyone, and thanks for joining us. Harpreet, it's good to see you. A long time, I think, since we've met. We chat all the time, but a long time since we had at least either a Zoom or I think we met face to face one time here in Israel, right?
Yep,
Uh,
yep. That was a good time. Yeah.
okay, great. So today we're going to be talking about fine tuning. Fine tuning came up in a few different sessions in different ways, but I think here's the first time we're really talking about it directly. And also, I've got a sneak peek at what we're looking at, and it's pretty deep stuff. It's not just understanding how to use it, but it's a bit about different aspects about how it works. So I think you'll have a great time. So just starting off, just want to say, so we mentioned questions on Discord, not over here. A big part of that is so we can continue to engage and discuss afterwards, and also that people can't join the session live can see it. So there are some motivations for it. So please make the extra effort, go there and ask the questions on general chat. And yeah, let's talk a bit about LLMOps space. So it's a global community for LLM practitioners. It's really fun to see people from all around the world join using the same thing, right? Of course, uh, English is still the most common use case of LLM-based apps, but also a lot of different languages. And yeah, and we're growing pretty quickly. So a few thousand people just in a few months since we started. This is, I think, going to be our ninth event, our ninth meetup, and we do one every, let's say, maybe 10 to 15 days. So it's not only about events, though. We started out by mapping out the different companies, etc., that are working in the space, and there are also a lot. We also were having all sorts of other initiatives like the consultants. So we just listed different consultants from different fields related to LLMs, and you can either list yourself or reach out to one of these consultants. So getting quite a lot of information all in one place. But yeah, but definitely most effort, or maybe the loudest thing we're doing is these types of events where we're trying to make sure that they kind of complete each other, in the sense that if you watch all of them, you'll end up being like not ignorant about LLMs, or maybe in a positive note, well-rounded. So I'm kind of lucky enough to be involved in, like, let's call it the syllabus of like how these sessions are connected to each other. But I think the main part is we're just getting some great speakers like Harpreet that usually have a lot of expertise, each one in a different field. There's some overlap, but there are also some special and unique aspects to each one of the talks. So let's talk a bit about the agenda for today before you start hearing from Harpreet. So talk about specialized fine tuning, introduction to instruction tuning, a few different aspects that have to do with model quantization, and a whole area called PEFT. Related to LoRA. I'm sure some of you have, some of you haven't heard of LoRA. You should have if you haven't, and maybe you'll get a bit of a deep dive to what that kind of feels like. So a bit about Harpreet. Harpreet it's surprising to when you talk to him to see how many things he knows well, right? He knows math and statistics, and he worked as an actuary, biostatistician, and built a couple of data science teams. And you can feel this through his chats on DevRel. You'll see it today, but it's really not. It's you can feel the depth in a few different aspects, and I really like that about him. So we met a few times ago. We met a few years ago for the first time. I've been in touch for a while, and I'm glad to finally have the opportunity to do a joint event. I think actually Deep Checks, not LLMOps, had a joint event with Deci, but I think Harpreet, I think it might have been before you joined. I'm not sure. Anyway,
It was after, but I
it
believe
was
that was
after. Oh, it was
in
after, but it
tele.
was a physical
Yeah,
event. It was physical
yeah,
event
yeah.
before you weren't. Okay. So yeah, and about me, so most of my time I spend working on LLM evaluation for deep checks, but also working on this community because it's not all about LLM evaluation. And I think my team and I felt that there's a really important part in just having one place where you can have all these different resources and see kind of the well-rounded picture of the different areas. So next event, next event is with Last Mile, and it's in a bit less than 2 weeks, and it's from prototype to production using prototype to production with LLMs. and it's a lot of different types of tricks and best practices that have to do with how to build an LLM based app. So if you or any of your colleagues want to speak at an event like this, then you can either reach out through the link or reach out to one of the moderators on Discord. And in the meantime, as you're listening to the event, I hope you enjoy. So Harpreet, feel free to take over.
Awesome. Thank you. I didn't know you guys are doing eval stuff at Deep Checks. I'm gonna have to check out what you guys are working on because that's been something that I've really been interested in lately. Uh, you know, uh, and just to say, like I do LLM stuff all day, every day, and I still feel surprisingly more ignorant the day after than I did the day before because things are moving so quick and things are changing so rapidly. But at least through this session, I hope to kind of give you an overview of kind of language models and how to fine tune them. We got a lot to cover, so I'm going to go through a lot of this stuff fast. But like I said, I'm here for you in Discord. If you got questions, tag me. I will answer them. I'll hang around all day today to answer your questions. Real quick, guys, I work at Deci. We build models.
Just one
Yeah.
second before you're diving in. I'm going to give the first poll.
Oh,
Second. So
yep.
the first poll I'm going to start off with, and we'll have one more poll in the middle of the session. So I'm launching it now. The question is, what is the current development stage of your LLM-based application? So the options are conceptualization and design, development and testing, production and deployment, or optimization and scaling. So please feel free to give your honest, direct answer, and we'll share the. How about you go through a slide or two, and then we'll share the results.
Yeah, sounds good. So I work at Deci. We do two things. We make fast models and we make models fast. We make fast models using our neural architecture search technology, and we make models fast using our inference SDK called Infery. Find us on Hugging Face. We got a bunch of models there: coder models, language models, and diffusion models. I'm going to pull up the agenda and just give you an overview of what we're going to talk about, and then we'll see the results from the poll, I suppose. So we're going to talk about just the difference between base models and fine-tuned models. Then we're going to talk real quick, just define terminology for you: prompt engineering, fine-tuning, RAG, PEFT. Then we're going to talk about fine-tuning for the GPU port, and that's LoRA and QLoRA. And then finally, we'll get into code. So it's going to be a lot of background knowledge before we finally get to the code, because this is important. I think you need to at least have some background knowledge of what it is that we are doing and working with before we start doing it, rather. Um, so I'll pause here, Philip. Should I move on or
Sure.
continue?
Let's show the results of the poll now. So as you can see, conceptualization and design in this case is 60%. Actually, it's more than I would have imagined, especially for fine tuning, which is I think it's let's call it more advanced than average topic. But it's interesting to see how from event to event there are some differences, and there's some I don't know if to call it noise, right? Because noise is a bad thing, but some variance. Development and testing is 32%. Production and deployment is 24%, and 2% is optimization and scaling. So kudos for those at the later stages, and for those of you at the earlier stages, we're here to help you get there to the later stages.
Yeah.
Anyway.
Results kind of fit my intuition, so that's
Oh yeah,
that's
okay. So
good to see confirmed.
you're less optimistic than I am.
Awesome. So great. Let's go ahead and just jump into real quick talking about the difference between a base model and a fine-tuned model. So first, let's define what pre-training is, and let's define what fine-tuning is. So pre-training essentially is we're exposing a language model to just obscenely large volumes of text, like books, articles, web pages, so on and so forth. And during this process, the model is going to learn to predict the next word in a sentence. And it's essentially learning connections and patterns between words and language in a self-supervised manner. So this is like the pre-training phase. And the artifact from a pre-training phase is what we call a base model, right? So what's fine-tuning? Fine-tuning is essentially nothing more than continuing to pre-train a model. We're just continual training a model. But in this case, we're doing it on a specific, usually smaller data set that kind of has characteristics of a task, right? And then during this process, we're updating the model's parameters on this new data set, focusing on specific input and output pairs so that we can guide the model's behavior, right? So we're essentially molding and shaping the model's behavior during fine-tuning. And so we end up with a few different artifacts, right? The base LLM is the artifact from the pre-training phase. You end up with a model that is great at, quote unquote, understanding and predicting language patterns, but it's not going to be able to follow a specific instruction that you might place in a prompt. Instruction-tuned models, it's like we mentioned, it undergoes fine-tuning, and it's going to be fine-tuned by a narrower data set. And in this case, we're trying to improve its ability to really follow instructions by showing it a bunch of pairs of instructions and responses. And then there's chat-tuned LLMs. In this case, we're just kind of training the model on a data set of chat examples so that the model is able to generate natural, coherent, and engaging responses. So instruct fine-tuning is going to enhance the model's ability to follow instructions and produce accurate outputs. And chat fine-tuning is going to enhance the model's ability to kind of engage in this multi-turn conversation. So let's make this example clear in the following. So I'm going to show you the generation between a base model and a fine-tuned model. So this is one of our older models. This is Deci LM6B. And you can see here, this is a base model. And I'm saying, okay, how do I make a good trap beat, or rather how to make a good trap beat? And you can see it's not necessarily following the instructions. It's just kind of completing the text. Whereas our instruction tuned model, in this case, this is Deci LM6B instruct. So we have 7 billion parameter models out as well. One came out in December, instruction tuned and base model. But you can see the difference in response, right? Like the instruction tuned model is actually giving me instructions on how to make a good trap beat. Chat tuned model, like if you've interacted with Chat GPT, you know exactly how these chat models work. They carry on a conversation. And when we get to the coding example, I'll share a link to the notebook. That's what we're going to be doing in that session. But before we do that, I think it's really important to kind of clarify some terms that you've likely heard thrown around town. So let's define some jargon, specifically these words: prompt engineering, RAG, full fine-tuning, and finally, parameter efficient fine-tuning. I'm going to go through these really, really quickly. So prompt engineering, we kind of know what this is, right? You've seen this. You're just giving an input to the language model, and the language model is giving you an output. And by carefully designing this prompt, the language model is able to kind of produce outputs that are more aligned with what it is that you want based on what you said in the prompt, right? So you can give it a few examples, you give it zero-shot examples, chain of thought examples, what have you. So prompt engineering is leveraging what's called in-context learning. So the ability for a language model to learn stuff within its context, not updating weights whatsoever at all. Limitation here.
Wait, Harpreet, I don't know if you started to see, if you've seen this at all. I've started to see some context where first the engineers doing prompt engineering know they're doing prompt engineering, but where executives or managers at the same teams, they're like, oh, we're not training anything, or we're not doing like the work. We're just using GPT. Like they like don't even perceive it as like doing research work, which is to me was astonishing, because at the beginning it was like, okay, of course this is an alternative for fine tuning or whatever. But like I think I don't know if it has to do with who explained it to them or whatever, but I don't know if you're seeing this at all, but I'm seeing in the lingo in some cases where it's treated almost like, yeah, it's part of the coding kind of.
Well, funny you mentioned that. I have a course dropping with LinkedIn Learning called Prompt Engineering with LangChain. And we won't get into it here, but I feel like there's a difference between prompting a language model, which is just giving the language model prompts, in a graphic UI, and then actually like doing the engineering behind the scenes. And that's involves a lot more coding and things like that. So the prompt engineering aspect really, there's more engineering work on the back end. But prompting, if you have a nice clean UI already, text in, text out, and you're guiding the model's behavior with that text. But yeah, so if you guys are on LinkedIn Learning, keep an eye out for that class. It should be coming in March. But this has its limitations, right? Because we talked about language models are trained on data. Sometimes that data is going to be stale or old, and we need to give access to new data. And that's where retrieval augmented generation comes in. So really quickly, I'm going to go over this. It's just coupling information retrieval mechanisms with text generation models. So we have this massive data set, it's a vector database. We have a bunch of documents that we're going to embed and store these vectors in the vector database. Then the user query is going to come in. It's going to be like a natural language query. We're going to take that, embed that using the same embedding model, and then a retrieval component is going to go and search the vector database for information that's related to that query. It's going to bring that back in, inject it into the prompt, and then we're going to generate an answer using that. So at a high level, that's it. Keep an eye out. I also have another LinkedIn Learning course happening later this year called RAG with Llama Index. So if you're on that, you'll find me there. Full fine tuning though. So the last two methods I described, we're not updating any model parameters whatsoever. We're just leveraging the fact that these language models have this emergent phenomenon of in-context learning, where we can put things in their context and they're able to quote unquote learn. But there's no updates of weights happening whatsoever. Fine tuning though, this is where we're full fine tuning at least, is we're updating all the parameters of the language model on a specific data set for the task at hand. So basically, we're modifying the behavior by updating all of the parameters, right? This is great, but it's expensive because language models are massive, takes a lot of compute, takes a lot of resources, and it's generally kind of hard to do. And because it's hard to do, researchers have come up with a method called PEFT, parameter efficient fine tuning. It's more compute and data efficient. It's a kind of the de facto way to fine tune a model if you're working on consumer grade hardware or limited resources. So the core idea is we're going to either adapt a small portion of the model's parameters. So we freeze the model and just unfreeze a few of the parameters, or we freeze the entire model and then inject these adapter layers into the model and update those. So really selectively updating only a few parameters, not the entire model. So in essence, we're concentrating on a few parameters. We're saving time. We're saving computational resources. Why does PEFT work? Well, because pre-trained models already understand language. So fine-tuning just needs to tweak these parameters for specific tasks. There's several different methods of PEFT. Like I mentioned, some are just adjusting a few of the existing parameters. Others are going to add new elements like adapter layers without changing the core model. And the latter is what we're going to talk about briefly. So we're going to focus on QLoRA, which is a PEFT technique. But before we get there, just let's talk about LoRA. So just really quickly, the benefits. Yeah.
Question, just because we aren't getting that, we didn't get a million questions, so I wanna give a spotlight to at least one of them in the meantime. There are three questions in the meantime. I'll give you one of them. So McBuzio Jr., I wonder if that's your real name or not, asked what's the best approach up to date for text to SQL, given what you just mentioned for the different types of let's call it fine tuning, training, the way fine tuning the
Yeah.
different prompt tuning.
Supervised fine tuning. Supervised fine tuning. Use QLoRA, some parameter efficient technique. The end result to do text to SQL is you need data set that goes from text to SQL. At the end of the day, it all boils down to the most unsexiest thing, which is data. So yeah, you'd use supervised fine tuning, which you'll learn how to do here. You can essentially like plug and play the data set and have this, the notebook I'm giving you, and just do it for any other task, right? In this case, the notebook we're going to look at is for chat tuning, but you can swap in a data set that is text to SQL and follow the same exact pattern, and you'll have a text to SQL model. But yeah, supervised fine tuning, use QLoRA. That's the way to go.
I will say about that, from what I've seen, it's a hard problem, and a lot of companies aren't getting the results they want, even when they're working really hard on it. It doesn't mean you won't, but it's hard.
Data sets, man, that's what it comes down to. Really good data sets, really good data sets, and training and hybrid. We have the traditional issues of machine learning, right? Hyperparameter tuning and all that stuff, which will drastically affect your results. Not only that, smaller language models are super sensitive to prompts. Even like the slightest change to a prompt will radically, alter the output you get from a language model. That being said, like let's continue on the presentation here. We got a lot to get through.
I'll address a couple of other ones because I don't think we're going to full answer. So,
okay.
Yes, I have a very basic question. With RAG and query engineering, the model parameters aren't changing. How is the model learning? The answer is the model isn't learning. You're changing the system. The model is staying exactly as is. It's kind of like tricks before and after and feeding something else into it. And we had sessions about RAG. I recommend looking at them on YouTube. Another question is how to choose different approaches related to use cases. There's a lot of sophistication here. I'm sure you'll hear some of it today. But I think, in my opinion, I think it has to do with what Harpreet just mentioned now in the last answer. You start off by creating a golden set or evaluation set. Everything comes after that. If you have a well-defined golden set with X amount of samples, I think there are a few different ways for how to create it. You can either go like by just sampling randomly from the distribution that you think you'll have, or from looking at edge cases, whatever. Once you have a golden set you trust, then your answer is easy. Everything seems complicated when you don't know like how to measure.
Awesome. Cool. So let's go ahead and continue on with QLoRA and LoRa. I hopefully got a chance to read this. I'm going to skip this slide now, but we need to first talk about rank. Rank is important to discuss at a high level because LoRa stands for low rank adaptation. So what the heck is a rank of a matrix? Rank of a matrix essentially is measuring how many kind of different directions you can go using a matrix, rows or columns. Technical term is kind of like the span of a matrix. This tells us essentially how many of these rows or columns are unique in their direction. A full rank matrix, this is going to be a matrix where every row or column in this matrix is unique. I mean unique in the sense that it's not, you can't create that row by mixing up another couple of rows. So we call this linear combination, right? And it's like having as many unique directions as there are the smallest number of rows or columns, right? So full rank matrix is a matrix where you have, none of the rows or columns are linear combinations of another row or column. A low rank matrix, this is, where some rows or columns can be created by combining others. So the end result is you have fewer unique directions than the smallest number of rows or columns. So this means that the matrix doesn't have kind of this full variety of directions that it can go. All right, so what's rank have to do with full fine tuning? Well, let me talk about that. So when we fine tune a model, we're essentially underlying the parameters of the model. So assume we have a 7 billion parameter model. And this model is represented by a weight matrix W. So during full fine tuning, we do something called back propagation. Back propagation, we have to learn a delta W matrix. And this is what we need to learn in order to update the original weights so that we can minimize some training loss, right? So the weight update matrix is a kind of combination of the W matrix plus the delta W matrix, okay? Both these matrices have 7 billion parameters. That's a ton of parameters, right? Like that's high computational demand and high demand on resources. This is where LoRa comes in. So it came out in 2021, low rank adaptation of large language models. The approach here is to decompose this delta W matrix into a lower rank representation. Okay, let's talk about that now. So again, we're fine-tuning updates with low-rank decomposition. So the pre-trained layers stay fixed. LoRa is going to add trainable rank decomposition matrix into however many layers you want to. Typically, you want to do it on the linear layers. This low rank matrix is going to have fewer degrees of freedom. It's going to store less information than the full matrix. This is a lot more efficient because now we are storing N by R and R by N matrices. So the total number of parameters we have now is 2 times R times N, which of course is far less than N squared.
I love this GIF, by
So,
the way. Addictive while you're talking.
yeah, it's quite nice. Shout out to whoever I stole it from. So somewhere on Google. So instead of so LoRa is not learning this giant delta W matrix. It's instead learning 2 smaller matrices, matrix A, matrix B. Turns out that we can approximate delta W by taking the matrix multiplication of A and B, right? Which ends up giving us far fewer number of parameters that we need to update. So we start by having matrix A initialized with small random values. And then we have matrix B. We just set everything to 0. And this ensures that at the beginning of the process, we're kind of maintaining the original pre-trained weights. And then we're going to adapt the weight updates in fine-tuning as low-rank matrices. Why does this work?
Just, just 1 second. I want to go maybe 1 slide back. So about that delta W that Harpreet's been talking about. So I just want to take you in a trip back to, let's call it the ignorant Philip, before I kind of thought about what now Harpreet kind of and I talked about before this. So when you look at the pricing for like GPT, when you look online, or then a lot of times you'll see a fine-tuned model costs more to host. But then I was like, okay, it costs like, I don't know, 3 times more, something like that, when you just look at it regularly. And then I was like, wait, I mean, are they hosting my model? Because if they are hosting my model, what, they have a machine up all the time, and that should be costing like a million times more, right? Because those GPT, the machines holding the GPTs are, serving them are probably pretty expensive and always on. And if I fine tune a model just for me, I'm the only one using it, right? So how is it costing only 3 times more? And then I think that this is the secret here, because really you can just keep the GPT as is, and you're only holding that delta W, only the diff, right? And then that's it. They have like to be able to serve my fine-tuned model. All they're doing is like adding it with that little delta W that weighs a lot less than the model, and that's the only thing they have to hold, like, especially for me. Correct? I know you're the expert here, but tell me if I'm missing something. And I think that's like the answer to the ignorant Philip that feels like he learned a
Well,
bit.
I'll start by saying I'm not an expert in anything whatsoever, but you are right. Yeah, the delta W, like what we're learning, the LoRa adapters, as they're called, super, super small compared to the full train model. So we're talking a couple of hundred megabytes, which is small, really small. Um, so yeah, so those adapters make it so you can have like just that base model, and then for this person's fine tune, we take that base model, combine it with their little adapters, and it works the way they want it to work.
So it's
But
kind of
yeah,
like
yeah,
called red glasses, or glasses with those shades that make it red instead of like painting the whole room red. Yeah. Anyway.
that's actually a good analogy to look at it. I like that. So
Um,
why does this work? Well, it turns out the LLMs are inherently low rank. So just the weight matrices of these models are already low rank. So not all the parameters are necessary. So techniques like LoRa, which are approximating the full fine-tuning update with this low rank decomposition, are just going to lead to more efficient and effective learning. Okay, so if LoRa is so awesome, why do we need QLoRA? Well, it turns out that LoRa has kind of become its own area of research. There's been so many different papers that have come out, all of which are kind of addressing this low rank adaptation of matrices. And the reason is these models are massive. They're huge. Just how massive are they? Kind of a back of the napkin kind of calculation is that each parameter in a model takes 2 bits of memories. So that means that you can multiply the number of parameters in an LLM by 2, and that will more or less give you the size of the model in gigabytes, right? And now when we talk about fine tuning, right, we got to talk about the weight gradient and the optimizer state. So the weight gradient itself is going to be 2 bytes per parameter. The optimizer state will be 8 bytes per parameter. So ultimately, we need 12 bytes per parameter for fine tuning. So then trying to you know, fine tune a 7 billion parameter model means that you need a GPU with like at least 84 gigabytes of GPU RAM to train. That's huge. So despite LoRa's effectiveness, the reason we need QLoRA is because we need to find some way to be more computationally efficient. And the trick here is quantization. So quantization makes it practical to fine tune language models in an environment with limited resources. So what is quantization? Essentially, quantization means that we're lowering the precision of numerical values in the model. This is going to reduce the computational needs. So floating point numbers, like you typically see in a neural network, they're commonly represented as 32-bit and 16-bit floating point numbers. Quantization is going to transform the model weights from this high precision floating point representation to a lower precision format, like int 8 or 16-bit int. QLoRA, on the other hand, uses this new format that Tim Detmers had invented. This is called 4-bit normal float data type. And so this is really, really nice because we're effectively lowering the memory footprint of our model, but at the same time, we're maintaining the quality and accuracy of the generated responses of the model. So
yeah,
QLoRA,
want to say something
yeah,
about compensation with the early generations of GPUs, not like now, but like 5 years ago, 6 years ago. So there a lot of the advancements of how you can train like a larger model with less good GPU we had to do with quantization. I still remember a friend of mine that trained like a really sophisticated model on his old computer, and then like he couldn't get it to run anywhere. So there's a lot of work that has to do with this whole field. So it's been continuously used across many different areas that have to do with the type of thing that the area that Deci is doing of like improving the computational efficiency, so forth. It always has to do at least somewhat with quantization, and any other technique you try, you'll end up also combining it with quantization. It's really hard to avoid it when you're trying to get more done with less.
yeah. So many different ways to quantize. Like you've probably heard these names. What I just showed you, QLoRa's quantization, we're going to implement this in SFT using bits and bytes, but there's also like GGUF, there's also GPTQ, there's also AWQ, and there's probably more that I haven't heard of that are out there. So if I'm missing one, let me know in Discord and I'll check it out. Um, Okay, so we've come a long way. So how does QLoRA work now? So essentially, we're combining the frozen. So we take that language model. We're now uh, representing this language model instead of this full precision. We're going to represent it in this new data type, this normal float 4. So we got now a 4-bit base model. We're going to learn some adapters on top of that through back propagation. We're gonna back propagate through the 4-bit weights into the adapters, and then we get some really cool, neat tricks for memory efficiency that we're not going to go into here. It's introduced in the QLoRA paper. One we talked about 4-bit normal float. There's paged optimizers and then double quantization. All techniques that have make uh, uh, all techniques of QLoRA that have made it accessible for us to fine tune and experiment language models. So my good friend Greg Loughnane of AI Makerspace, if you guys don't know AI Makerspace, follow them on YouTube. Hands down, the absolute best live sessions and tutorials that I've ever seen. Proud to be a part of their community. Here's the TLDR of this presentation. Fine tuning, we're modifying behavior by updating parameters. PEFT, we're fine tuning with fewer parameters. LoRA, we're fine tuning using factorized matrices. PEFT LoRA, fine tuning, is we're modifying behavior by updating fewer parameters using factorized matrices. Quantization means we're representing high precision numbers with low precision. And then PEFT QLoRA fine tuning is we're modifying behavior of a model by updating fewer quantized parameters using factorized matrices. Awesome. Whirlwind tour of fine tuning and all that stuff. Now let's get started with some code real quick in the little bit of time that we got left. Oh no, I got enough time to go through code. Here's what we need to get started with QLoRA and Hugging Face. So we need a language model. In this case, we'll use Deci LM 7B. We need the tokenizer. So, get the tokenizer that's associated with the model. It would not make sense to use a tokenizer that's not associated with model. We need a data set. We need some configuration files, and we're going to set that up with BitsAndBytes and LoRa config. And then we need to toggle hyperparameters for SFT trainer. This is not a session on hyperparameter optimization, so we're not going to focus on that too much. Awesome. You guys
So
ready to code?
as you're getting the code up, I'll launch the second survey.
Yeah, go for it.
All right, so the next survey is about fine tuning specifically, and not about the general state of what you're working on with LLMs. So the question is, please select the option that best describes your experience with fine tuning an LLM. One of them is I've never tried it. The others I've experimented with fine tuning as a hobby. Others I've tried to fine tune for my team's project. And the last one is our team has fine tuned and has a fine tuned LLM in production. By the way, I in the past I used to recommend like fine tuning, just drop it. Like think about it later once you have a few thousand users and start thinking about it. I did recently encounter a few use cases where fine tuning was a more elegant and quicker approach. I think there is some art in understanding when the fine tuning is better than the RAG, which is my um, which is my elegant way of kind of stepping down from the tree and saying, okay, I was wrong, right? There are some cases where fine tuning is a good solution. But yeah, but still, I think there are a lot of cases where you can do it with fine tuning, but you don't have to. And you could just wait with the quality to improve kind of naturally.
Since we have a couple minutes before I get into code, I want to chime in here. I think this is a great point you're mentioning. So, why fine tune a model from behavior when I can kind of mold a model's behavior with a prompt, right? Okay, fair enough. That's a fair question, right? Um, let's say I want my model to only output like JSON outputs, right? Um, most models are smart enough to give you JSON outputs um, through prompts and through some examples, right? But the thing is, that costs money in the sense of we're taking up space in our context window, right? We're taking up space in our context window. That means more tokens. More tokens means more processing. More processing means more money that we need to spend on compute, right? Eventually, that's going to add up, right? And if you're looking for places to cut on cost, then maybe you want to fine tune, and maybe you want to fine tune specifically a model that will take whatever input you want and then always only output JSON, right? So now you can eliminate, those 1,000 or so tokens that you do for every single request for the prompt and just directly get the behavior that you want. And so that ends up saving some money there. So maybe that's like a clear-cut example, hopefully, uh, for, why do fine tuning when I can maybe, use in context learning to drive the behavior that I'm looking for.
Wait, so I'll share the results now real quick. All right, so you can see, so 43% said I've
Okay.
tried it, experimented with fine tuning as a hobby, 33%, not bad. Tried it for my own team's project, 16%, and a bit less than 10% is as a fine-tuned LLM in production. That's a lot. That's a lot. I think
Yeah, 25% or so. Um, cool. That actually like have done this. That's great to see.
care about it for their actual team. Yeah, and it's gonna go up. It's gonna go up. By the way, I don't know what your experience was. My experience is that the APIs, just working with it is really inconvenient. I think that's gonna improve also, but just the technical aspects of doing fine tuning, at least in some of the cases, is not straightforward. And then yeah, and then definitely with the API type models, then you like send it somewhere, then you go back and look at it, and I think there are also something that has to do with cost. I think with Azure, they're like if you have like something fine tuned, there's like some like upfront costs that are just associated. I think there are a lot of things that aren't just scientific that have to do with why it's an obstacle to do it. But
Yeah, yeah,
time will tell. I think it's going to become more popular as it becomes easier, just technically.
yeah, absolutely. So I'll go ahead and share my screen back up. So for the 25% that have done this, you've seen this before, and you can feel free to call out any anti-patterns that you see me leveraging here. I'm still always learning. Like I said, I'm
Oh
not
no,
an
wait,
expert in
it's
anything.
more than 50%. More than 50% experimented with it also as a hobby.
Ah, got you. Awesome. So I'm just going to quickly walk through the notebook to kind of show you what we're doing. This notebook is not live or active, using the A100 to train this. So just keep that in mind that, you need to have an A100 to run this notebook if you want to do so at home. But let's go ahead and just, kind of start at the top, setting the UTF encoding, installing stuff, creating dictionary. None of this stuff is interesting. This is where it gets interesting. All right. So this is the bits and bytes configuration. This is essentially what we need to quantize our model, right? So here in this model, we're going to load it in 4 bits, right? We're going to use double quantization. We are going to use the NF4 data type here, and then just use torch bfloat 16, so that's brainfloat 16 data type, right? This right here is the quantization right here. So that's pretty much what we need to kickstart. So this is like what separates QLoRA from like, regular LoRa or full fine tuning is just the values that you put in this quantization configuration. I encourage you to go to the source code, bits and bytes config on Hugging Face and just kind of look at all the arguments you have available to you. It's always good to look at the source code. We're going to use Deci AI 7B in this case. We're going to, of course, load it from Hugging Face. So that's basically what we're doing here. We've got the tokenizer, nothing special happening here. Then we're going to load the data set. So the data set I'm loading in this case is you have to log in for it. This is the LM-sys data set, LM-sys chat1m. So this you have to kind of give your consent to use it, but this is the data set we're using. Huge data set, 1 million rows. So we're going to kind of subset it because this is just a tutorial. So I'm only interested in English rows, and what I'm going to do is insert into every one of the rows the system message, so the system prompt. So that's what we're doing here, because we're going to eventually leverage the chat template from the tokenizer that we have. So load the data set, filter it, append the system message, drop rows that I'm not interested in, drop columns that I'm not interested in, shuffle the data set, and only select 25,000 rows. And you can see that this is what the data looks like. So this conversation, right? This is just the multi-turn conversation between a user and a bot, right? And this is what we are going to train the model on. And so we want to train it in a I can't exactly train on lists of dictionaries. I need to train on just one giant string. And so that's what this is doing here. We're applying a chat template from the tokenizer. So we have the chat ML template as part of our tokenizer, and it's going to format like this. So I have a nice string. And so we could see here, like here's the ground truth of the example above, and here is what the input is going to be, and here's how the model is going to predict it, right? And so you can take a look at that. This is doing nothing special here. We're just splitting the data set. We have train, val, test data set. I'm going to go in now to the data set that I subset, and I'm just going to add some stuff. Specifically, I'm going to add start and stop tokens to every turn in the conversation. This is going to help the model because these are special tokens in the Deci LLM tokenizer, these start and stop tokens. The model will know that this is a start of one sequence, end of one sequence, so on and so forth. So, this kind of will help the model have that behavior of that turn taking with those special tokens.
By the way, about the cell above, I just want to say for me, it's like almost moving emotionally, kind of, right? Because the whole test trains, validation, whatever, splitting is something we're used to from like the world of training, and then we kind of like lost our moving to LLMs. We kind of lost our origin or whatever, and not seeing this. So seeing them work together is important. I just want to say all the different types of leakages you can have, all the different types of junior mistakes. They're a bit different here, and there's some adaptation when you're dealing with fine tuning to not make those stupid mistakes, right? Like so a lot of attention the first times you're doing fine tuning, and try not to be very very happy the first time you get like results that are like
Yeah,
impossibly good and so forth.
yeah, absolutely. So formatting the chat here, and then this is just logging. This callback for logging so that I can visualize stuff later. Of course, with SFT, you can send stuff to TensorBoard if you'd like. And now this is an
Ah,
important part here. So this is the LoRa configuration. And sorry, was there a question?
I'm saying here we are. That's a good, great. This is what we were waiting for now, right?
Yeah. So this is the LoRa configuration, right? And so the R and alpha, these are the parameters of that update matrix, right? Um, these values are hyperparameters that you can change. There's a great blog by Sebastian Rashka, who's done, I think he said like thousands of experiments using LoRa. And he's found that as a general rule of thumb, the value you choose for alpha should be 2x the value you choose for R, right? The target modules, in this case, we're targeting just for DeciLM, these are the linear layers that we want to target. We have the dropout rate here, as well as the couple other parameters here. Just make sure I'm looking at the right notebook here. Yes, yes, indeed. All right. Here this is it. This is LoRa. This is gonna take care of everything under the hood for us, which is nice. Of course, you can always go look at source code and kind of see how it's going. But the combination of bits and bytes, quantizing the model to 4 bits using normal float 4, here using the LoRa config, this is what it takes to now use SFT to perform QLoRA fine-tuning, PEFT fine-tuning. TRL trainer here. These are training arguments. Here you are free to choose whatever training arguments you want. No, just you're free to do that. You'll notice here I chose an absurdly low learning rate, kicked up weight decay a little bit, and used this scheduler. And this I kind of just did. Obviously, you want to experiment with this, right? So maybe sometime in the future, uh, Philip will have a session where you have somebody talking about hyperparameter optimization for fine-tuning LLMs. I think that would be an excellent topic, but that's gonna be up to you. So here is kind of the results. Let me.
But I think one thing that is pretty clear is that you can get a lot of stuff. I think there was also a question about that, about number of samples. You can get a lot of stuff done with just a few hundred samples, which is very not
Absolutely.
like, so that's a
Yeah.
lot like what you might know from computer vision, those of you that tried with it, and not like the classic model training where that use, like for the classic tabular data, training a model with like, I don't know, 300 samples, that used to feel like it's a special specialization, right? For people in like oil and gas or whatever, where there aren't a lot of samples. So here it's pretty standard, and getting, you can definitely get a lot more done if you have 10,000 labeled samples or samples that kind of represent, but yeah, it's really interesting how much work, and you even have to sit down and wait for it to finish training when it's just a few hundred samples. But that's
Yeah.
that's
Yeah, in this case, I trained on 17,500 samples. The total number of parameters I was updating was 56 million, far, far less than the 7 billion parameters. And it took me 9 hours. So look, I obviously could have looked for more efficiencies. Learning to get the most out of my GPU is something that I'm actively learning about. Like I said, there's a lot to learn, so little time. And I probably did not use best practices for this part, but there is a great blog by Hugging Face that talks about how to get the most out of your single GPU. That being said, just want to blaze past this. You can see it's learning. That's quite nice. Let's take a look at the loss curve. So loss curve, I mean, it's not overfitting, so that's nice, but it looks like I got trapped in local minima here, right? Because it's kind of tailing off here. Something that I would go back and do, uh, uh, you know, get, just to make this better, is to maybe kick up the learning rate by a couple of orders of magnitude, maybe as much as 3 orders of magnitude, and choose a periodic learning rate scheduler, like cosine or something. Preferably kind of implement a learning rate schedule that has like a warm restart to it to kind of kick it out of this local minima. So this obviously it learned, it did learn, but it obviously got trapped in local minima. But you know what? The point here is not to train the best chat model, it's just to show you the pattern for training a chat model. Then you can train, you can save the model. In this case, I saved the model to my Hugging Face repo. You can find me on Hugging Face under my name, Harpreet Sahota, and the model is here. And you can take it and hack around with it. I encourage you to hack around with it. First thing is just let's vibe check the model. So after the model has been trained, like we're done training the model, guys. So round of applause. We have trained a model. We fine-tuned a model for a chat, and um, you know, pattern is going to be like this using SFT. It makes it quite nice. I've not hacked around with any of the other libraries yet. That is on the agenda, but SFT, this is the pattern. It's quite nice. Then we can vibe check the model. In this case, I'm just seeing, okay, is this model going to complete a turn of conversation? And it looks like it is able to complete a turn of conversation, which is the behavior that I wanted to take on, right? So vibe checking the model is one thing, but how do I actually evaluate it? So then I create a ground truth data set. This ground truth data set is going to be using just the test set, and I'm just doing some manipulations here of the test set to end up with a data set that looks something like this, right? So I've got the full-on conversation, right? Then I've got the ground truth completion as it is, and then the string of that ground truth completion, which is just that. This is going to be useful for later evaluations. Here I generate the chat completions. Again, these are generation parameters. You can hack around with these as you please. Come up with the generated uh, results. In this case, I only did 100. And you can see I've got the conversation, ground truth completion, and ground truth string. And then I'll also have generated completion, generated string in that data set. Cool. So let's evaluate this thing. So I chose to evaluate it in a couple of different ways. One was the rogue metric. This is just measuring the similarity between generated responses and a reference one. It's essentially looking at n-gram overlap matches. Not necessarily the best thing to do, but it's something kind of, finger in the air and kind of, gives me some direction. And I calculate the overall, I don't know how to say this, rogue or rouge, whatever it is. And I calculate the overall rouge score here for n-gram overlaps. Not looking good, but is n-gram overlap the best way to evaluate a chat model? I don't know. I don't think so. But this gives me something at least to look at. More interestingly, though, is I looked at this thing called uni-eval. So uni-eval, it came out in this 2022 paper, Multidimensional Evaluation and Dialogue Generation. They have a series of models, pre-trained models called uni-eval models. I'm specifically using the uni-eval dialogue model. This is measuring for the naturalness, coherence, engagingness, and groundedness of the model. I know I'm running out of
I
time.
have to show you what we're working on. You'd love it, I think. Let's
Yeah,
in the
you got
evaluation.
something like
I don't
this?
care what you showed it, but I'll show you. Yeah, yeah.
Oh, dope, dude. Like send me some stuff to hack around with. I'd love it.
Uh,
Um, but yeah, you guys will have the notebook. I'll send a link to it right now. But now we're evaluating it on these metrics, on these kind of axes, right? And go ahead and calculate it, and we can see that. Let's just scroll down here. It scores pretty high on these. So not too bad, I guess. So engagingness and overall, it seems to do decently. So gives me some idea of how well this chat tune model is performing. The one thing that I did not do is actually chat with it. So I encourage you, my friends, to go to my Hugging Face repo, Harpreet Sahota, that's my name, right? The model is right here. This is the model that you are going to use, and
Harpreet,
chat with it.
I would suggest you send them in the chat here. You could also put it in the Discord, but let's also put it in the chat here, a couple of links. Maybe that one, yeah, and then the other one, just so we don't miss it in terms of time.
Yeah. Cool. I'm done though. That's pretty much it. I know I covered so much. Hope you guys.
Yeah, and I really, really
Yeah.
like the combination of presentation and code. Judging by the fact that almost everyone stayed till now, I think is a great indication for that. I will state a couple of things. So as you might have noticed, Harpreet has a very large following on LinkedIn. So follow him if you aren't yet. He usually writes about interesting stuff. If you find anything boring, then you can yell at me and say it was my fault. You can also he also has a couple of initiatives that have to do with different courses and so forth on LinkedIn Learn. I think there's a lot to learn from it, and I hope you saw for the presentation today that it's really technical and really touches the depth and different angles. And also, I think at the beginning you had a slide about what Deci's working on. So Deci are both creating different types of open source models that in some of the cases they're the way at the top of the leaderboard and so forth, which to me is really cool because I knew Deci in the past as like a mainly kind of computer vision focused type company, and then boom, seeing them like at the top of the leaderboard with an LLM, to me that was amazing. But then they're also doing all sorts of things to make uh, running more efficient and so forth. I think Harpreet, at some point you also told me you're doing like side research on your own, university stuff that have to do with the that have to do with NAS, right, with neural architecture work. So anyway, but I think both Harpreet and the team at Deci, there's a lot to learn from them. So I'm really glad to have you here and host you here. And again, the Discord's wide open, not also before the event and after. And hopefully Harpreet will also be there to answer the questions related to now. Feel free to engage with either one of us here. A few of the questions that have to do with evaluation that you kind of raised here. So we did have a separate situation where we kind of showcased what we're doing in DeepShakes with evaluation. So just go on the YouTube if you're interested in that specifically. We didn't do a combination though of evaluation and fine tuning. That's really interesting, and you can do it a bit differently. But there is a session about that you can see on YouTube. So feel free.
I'm gonna check that out. Yeah, definitely. And thank you for the kind words. I didn't want to come off as too self-promotional in the beginning. I kind of glossed over that. I appreciate you saying all the nice things about Deci. And yeah, if you guys are on LinkedIn Learning, I've got so much coming out this year through the platform. I've got a computer vision course already, the course on prompt engineering with LangChain that's coming out in March, Llama Index and RAG, second half of the year. And then 2 more courses about using Hugging Face. I've got 2 books that I'm authoring with Wiley. One is practical retrieval augmented generation, and the second one is still a secret. And so keep an eye out for those things. And yeah, connect with me on Twitter and LinkedIn if you like. And I'll hang around and answer questions today. So I'll see you guys in the Discord.
So great having you. Reminding again, next event is in a bit less than 2 weeks, and it's talking about taking an LLM system from the first POC to production. A lot of challenges there. So I sent the link early on. I'll send the link. I'll send the link again here. It's with Last Mile AI, and hope to see you there, just like we saw you or kind of saw you here. So have a
Awesome.
great morning, afternoon, or evening, depending on your location, and we'll be in touch.
Go Niners. See you guys later. Bye.